Vertical and horizontal stretching and shrinking on graphs. A vertical stretch or shrink is the result of multiplying the y value by something. If you multiply the y value by a number bigger than 1, it's a stretch. If you multiply the y value by something between 0 and 1, it's a shrink. So let's look at some examples here. Here is my first graph. My basic function is y equals the square root of x, which is this basic graph. We see the graph, and we see a few ordered pairs on that graph. If we take and we multiply the y values here by a constant value of 2, the first y value, of course, will still be 0. But then the second y value, 1 times 2, will give us a 2. And the third y value, 2 times 2, would give us a 4. So this results in a graph that is actually moved up higher. So we call that a stretch. This is a vertical stretch because we multiplied the y values by 2. In this next example, we multiply the y values by 1/2. So if the y values multiply by 1/2, what happens is they actually get smaller. So instead of the original graph being here, having a point here and here, those points are actually lower. So this is a vertical shrink. So let's look at this graph. And let's sketch 2 times this function. Okay? So if these are the y values I have for my original function, 2 times my original function is just going to multiply each of these y values by 2. So my first one would be a 4. My next one would be a -2. My next one would be a -4. Then I would have another -2. And then I would have another 4. So my new graph would have the point -2, 4, -1, -2, 0, -4, 1, -2, and 2, 4. So what happens is this graph has been stretched. Let me see if I can get a decent looking picture there. So here is my graph. Again, the way I'm having to graph this on this software is not the best in the world, but you see that this point moved up to here. This point moved down. This point moved down. So they have all been stretched further than they originally were. A horizontal stretch or shrink is a side-to-side movement. So here, let's look at our ordered pairs. I think you can see it a little clearer. My y values are going to stay the same, but what happens here actually happens to the x coordinates. Here, when the x's start out as -2, -1, 1, and 2, if I adjust this and I want to graph f of 1/2 x, it actually forces my x values to be multiplied by 2, multiplied by the reciprocal of the value you see in here. So here the x values double, which results in a stretch. And here the x values actually are cut in half, which is a shrink. So if we look at this and we want to sketch the graph of f equals 2x, the adjustment I need to make here is to my x values. I need to actually use a half of x for my x values. So I'd use half, I'd multiply 1/2 times x, but I'd keep the same y values. So half of -2 would be -1. Half of -1 would be -1/2. Half of 0 is 0. Half of 1 is 1/2. And half of 2 is 1. So now I use this column for my x column and this column for my y column. So I have the point -1, +2, -1/2, -1, 0, -2, that point didn't change, 1/2, -1, and 1, +2. So it's almost like this graph has just been kind of squeezed. I know that's hard to see there on this, but that's where the new graph would be.